Welcome to the Control Engineering webcast, IT Technology in OT Environments, Key Trends from the Field, sponsored by PTC. I'm your moderator, Mark Hosky, and I'm happy to join you today on behalf of Control Engineering and CFE Media and Technology. Here are some tips to help you get the most from today's webcast. If you're experiencing issues with your slides or audio, refresh your browser or click the Refresh Media button directly under the presenter's picture. You can control the volume of this webcast by adjusting the volume on your computer or by adjusting the volume on the webcast platform. If you're having technical problems with the audio or the slide presentation, click on the question mark at the top right corner of your screen to access a list of system checks to try before contacting an online technician. But if you do need a technician, type a message in the Ask a Questions box and someone will get to you as quickly as possible. Individual technical questions will be answered in the Answered Questions box. Type questions for our speakers in the Ask a Question box on the left side of your screen. The live Q&A session will begin after the presentation concludes. Today's webcast is being recorded. You will receive an email within a week with the link to the on-demand event. To download a certificate of completion and a PDF copy of the presentation, use the Event Resources tab on the left side of your screen. Those documents will also be available with the on-demand version of this webcast. Now I'm happy to introduce today's distinguished speakers. Chris Misture has a unique combination of skills, a hands-on understanding of manufacturing digitalization, and the ability to communicate to digital transformation to audiences who understand what this is and where they need to go, but are unsure how to get there. Chris considers himself a lifelong learner who combines technical knowledge with the ability to spot waste and apply systems thinking to a solutions approach. His work with manufacturing data and in the IoT community has led to speaking at several conventions. Chris recently formed Mr. IoT out of the desire to help businesses grow and thrive through evolution and optimization. The fourth industrial revolution is here, and Mr. IoT's mission is to help manufacturers embrace Industry 4.0 and bring the concepts of smart manufacturing and the industrial Internet of Things to their businesses. Jeff Bates leads the product marketing area for ThingWorx' portfolio of edge and connectivity applications, including ThingWorx and industrial connectivity, KEPServer EX, and all Kepware products, the ThingWorx Edge microserver, and the ThingWorx Edge SDKs. Jeff works closely with end users, partners, and industry experts to develop relevant, high-impact messaging on the value of ThingWorx connectivity solutions. Prior to this role, he consulted with leading manufacturers, helping them define growth strategies and tactics. He received his MBA from the Darden School of Business at the University of Virginia. Thanks in advance to the speakers for assembling the glossary of acronyms used in their presentations, available in a couple of slides near the end of the presentation, and it's also downloadable in the downloadable version. Jeff, please go ahead.
Great. Thanks very much, Mark. So I want to start by setting the stage for what folks can expect today. And really our hope or our goal for this session is to illustrate how technology that was created for IT practitioners can be used to benefit operations or OT practitioners. So let me just say up front, I'll start by saying that I fully recognize that IT technology actually translates to information technology. We're in a little bit of a ATM machine or automated teller machine type of situation here. But really technology that came out of an IT environment or that was born in an IT environment is much more cumbersome. So we'll use IT technology throughout the presentation and hope you can forgive us for that. So again, the thesis of the webinar today is really that operations or OT engineers can benefit from technology that is really traditionally used in more IT-focused environments. And that, while certain IT technologies have been used in OT environments for some time now, that it's not new that IT technology is used in OT environments, we're actually seeing the need for a bit of a paradigm shift for manufacturers and other production organizations to be able to fully take advantage of these technologies. And of course, as we know, the most valuable section of the presentation is always around examples from the field. So we have 3 examples of technologies, IT technologies, that have been successfully deployed in more operations or OT environments. So we'll go into details on those. And then lastly, just as Mark said, we do have a glossary of terms. We use a lot of acronyms in this presentation. We believe that they're all fairly common acronyms like PLC or SCADA that anyone working in a production setting who has an interest in technology would be familiar with. But in case there are also a couple of IT-focused acronyms in here, so we do have that glossary of terms that's downloadable, as Mark said. So without further ado, let's dive in. So to give a little bit of a preamble to this, there's been a lot written about the convergence of IT and OT, and I think that's for good reason. It's a subject that's worth writing about. But, and that's true because when you define it broadly, it's one of the most complicated challenges that we face as an industry. That said, though, there are many different facets of the challenge, from how the two different groups interrelate on a personal level to the processes to actually merge these two groups, to organizational structure. Should they be 2 organizations? Should they be 1 organization? And those are all definitely topics that are worth discussing. But for the purposes of the conversation today, we're going to look at a very narrow piece of that challenge and looking specifically at how technologies that were created in IT environments can be useful to engineers that are working in OT or production environments. So we're really going to take the OT point of view here, the operations point of view. The examples that we show will be of manufacturers and process organizations getting value from these IT technologies. If you're not on the operations side of the house, we believe that this material can still be valuable to you, but we want to make sure that everyone is aligned on the purpose and where we're going to take the discussion today.
Yeah, Jeff, this is Chris jumping in. As I'm sitting here, I'm kind of thinking about the people listening in. You know, I'm wondering which side are the people on that are listening into our webinar, and will they really be able to get as much as we promised them, and we really hope to. And as you kind of have demonstrated here, the different technologies, the IT side and the OT side, they have matured at their own pace, to their own needs and their own requirements, right? You can't really put a robot in an IT environment unless he's serving you drinks as I'm sitting on my couch updating servers or something, you know.
Right. Yeah. No. Good point. That it's been much more of a we've seen much more of operations borrowing technology from information technology, and I think that is, as you say, a result of kind of both of them maturing at the same pace, and also some of the key requirements of the operations space. With one example would be determinism, that isn't quite as necessary on the IT side, but if you're cranking out however many parts a minute, that determinism is absolutely critical. So just to provide another caveat, we recognize that technology has to drive value, and it's important to note that even though we're focusing on the technology piece, we're not advocating for or promoting the use of technology just for technology's sake. What we found, and Chris can speak to this at length, I think, but implementing technology without changes to processes or training people, it usually just doesn't get the business benefits that we're all shooting for. So to to give a concrete example of this, we see this in a lot of cases in the connectivity space. There are a number of organizations that simply connect to their production assets for the sake of connectivity without a specific use case. But without that specific use case and without it involving the actual operator, as shown here, the organization doesn't get the full benefit of that technology, because the person who's doing the work and making the decisions is not involved in the process and is not seeing the results of that connectivity. So,
totally. I totally agree. Sorry for jumping in again.
No,
as much as these initiatives, I believe, must be driven from the top, also it's a bottom-up initiative as well, because the people that are on the floor, that are touching the product day in, day out, they're the closest ones to the customers, and they know the intimate details that they need to know to produce the right products at the right time. It's very important to involve the operator.
Yeah, so I think that the takeaway here is really that implementing technology can be fairly complicated. Is more than just understanding the technology, is really understanding the people and the processes. So just to give the example on the connectivity front here, you still need to implement the technology, connect the machine, but there's a lot more to it than that. You need to connect and have a use case in mind so that you know whether or not it makes more sense to send data directly to the cloud, or in some instances it may make more sense to have that data be at rest in an on-premises database or solution. And then, again, just to illustrate some of the complexity that comes in here, you really need to add context to that data. And what I mean is that data, once it gets into either of those solutions, isn't necessarily formatted in a way that makes sense to anyone. It could be, Modbus register 40,001. And when I say you need to add context to that data point, I mean you need to change it from Modbus register 40,001 to this is a Boolean value that represents whether or not a particular machine in a particular plant is running or not. And it could be even more that's just an example, but it could be even more complicated than that. You may need to add engineering units. You may need to do some scaling. You may need to potentially even add some spatial data. And that's a huge challenge today. And it doesn't end there. You need to work with the operator, as Chris mentioned, to understand the data that's specifically required to improve decision making. And once that's identified, you need to deliver that data in a way that's most useful to the operator. And that could be a summary screen that's sitting above the entire line. Could be more of a personal dashboard on a tablet, or it could even be augmented reality data on a headset in an environment that the operator needs to be using both hands while viewing the data. So
right,
again,
and that context. Sorry, that context also has to kind of roll up through the supervisor and management, upper management layers too, right? Everybody's going to want to see something different about their data. And I see a lot of platforms that are coming out. Some of them address this issue, but a lot of them do not. And in the end, you have to do what drives value. And at the same time, you have to think about that this is going to be a learning experience and keep that in mind. But in the end, the goal is to mature within this Industry 4.0 space.
Yeah, absolutely. And just to close out on this slide, I think I think one of the key points for folks to take away today, this is a little bit of a caveat, is that everyone should recognize that when implementing these technologies, there's a ton of work to be done on the people and process side of things, not just around understanding the technology and getting it implemented. So that's just, we want to be transparent here. A lot of work to be done in implementation, but there's also a ton of value to be captured. and so, Chris, I think here it makes sense to talk about even a little more in terms of giving folks a little bit more context around what we're talking about here.
That'd be great. Thank you. So this slide, I took it out of Clarity First. It's a recent book by Karen Martin, and I love this slide because it really shows you what types of data exist out there and where the value can be captured. You know, at any given point in time, a factory or a process or any kind of business, they need to have feedback on what is going on with the operation, right? Where's the heartbeat? And this data should be there available in real time. You know, there's a lot of complexity to how to give context to the data and be able to turn that information and then derive decisions from it. But in essence, it's breaking it down into three separate categories of data: is demand data of the work that's coming in from your customers and how that affects your schedule, for example, or the status data of what's going on underway right now and where's our capacity, or where are we having issues with machines or people or anybody, and the outcome data, which is hour by hour. You know, is there a dashboard for what is our target? And even if that target is made up in the beginning, you start to learn and understand the performance characteristics of the machinery and people together, and be able to set goals, either increasing throughput or reducing quality defects or other things too that are important to your company. And the last piece that I believe is important is these have to be quantified. If you can't measure something, you can't improve it. And that has been a big challenge for a lot of people, is putting numbers, looking at their current state, and what numbers do we gauge ourselves by, and what are the values behind the company, and what's important. And because in the end, you want to know if your experiments are true. Are you addressing root causes of problems? And that's one way to do that, is to be able to measure it over time.
Right. Yeah. I think you in your bio, Mark mentioned the importance of systems thinking and thinking about, you know, capturing the right data to actually optimize the system is critical and goes way beyond just, you know, understanding a technology and being able to implement it. So there's a ton of critical pieces to this puzzle. So we do also want to acknowledge that technology is constantly evolving, and this idea that IT technology has been adopted by OT practitioners is not new. You know, there's a couple of examples of this happening in the past, and a great example of that is virtualization. Clearly, a technology that was developed in the IT space, but has been widely adopted in factories and other production environments. But that said, you know, there's always folks who push back against this type of advancement. Chris was telling me about a story around when PLCs were first introduced, and there were folks who said, you know, we got to double down on the relays. These work, and so we shouldn't mess with them. And you know, you can walking into any automated facility today, you can see what a step backward that would have been had we all listened to those folks. So
yeah, and that's a story that when I had a conversation about 6 months ago with my friend from Texas, who's a retired oil and gas electronics engineer and SCADA guy. That's what I was kind of telling him, like, you know, there's so many technologies out there that are available in IT or commercial, but, you know, controls engineers won't touch them because, sure, there's certain specifications they have to meet, either UL standards or, you know, specific enclosure ratings for dangerous areas. But then he said, you know what, Chris? They had the same fears and concerns were happening when relay logic was transitioning over to PLCs. And I think it's an evolution. It just takes time. And as much as we call this industry 4.0, maybe I don't know, maybe there's a better name for it nowadays. I don't know.
Yeah. So I think certainly what we're trying to do here today is just show that this new IT technology does have the potential to create value, and it's worth taking a look at. But at the same time, we do think that there is a bit of a paradigm shift associated with this technology, where before, with some of these technologies, you could do just kind of a like-for-like switch, where you're switching out a physical server for a virtualized environment, or a PLC for a software-based PLC. But today, we actually think that to fully take advantage of some of these architectures, you need to potentially have a shift in architecture. And so to dive into that a little bit more, we'll just highlight the existing, or what is really a traditional architecture. And here's the type of environment where you could just make a like-for-like switch and get a lot of benefit out of adopting IT technology. But we believe that in order to fully take advantage of some of these new technologies, there needs to be a little bit of a change in the thinking. And we're not saying certainly that the existing production facility has to change in terms of ripping and replacing existing hardware and replacing it with all new connected hardware.
No.
Right. It's just not an option. But we are seeing this idea of wrapping and extending the existing environment with new tools and functionality, potentially adding some edge compute to push workloads to different levels of this environment, and being able to access a lot of this data in an Industry 4.0 or IoT platform without having to go through all the way up through sequentially every level.
Mm-hmm. I guess, Jeff, I want to add to that. I just thought about this. It's kind of like thinking about some of the OT technologies. They definitely have a purpose for what they were designed to do. But right now, you start talking about data and bridging the gap between business systems and, say, an HMI screen, right? SCADA has existed out there for a long time, but with, say, the advancement of HTML, right? You can't necessarily throw an HTML page onto a Maple Systems HMI. So even though those HMIs are really good for controlling the machine and given some status of the machine, they can be supplemented with other technologies to take that next step, but not replaced.
Absolutely. Great. So with that introduction, let's dive into some of these examples that we referenced. So the first technology I wanted to introduce is what we're calling data flow management. This is definitely not an official term for the technology. We weren't able to find a super official term. It doesn't seem like the industry has coalesced on a term for this technology, but that's what we're calling it. So let's, in order to make it a little bit more real, let's get into an example here. So what we're calling data flow management really allows the user to bring the data in via one source, optionally perform some processing or transformation on that data, and then send the data to another destination, potentially via a different pipe or a different protocol. And one of the great things about these tools is that they really allow you to do this in kind of a drag and drop, more configurable user interface. And just to show some examples, I've included a handful of hypotheticals here. So in the top example, you've got data coming in over MQTT, which for those of you who are unfamiliar, it's a very popular protocol in the IoT, and you could say this data is hypothetically coming in over wireless sensor. A handful of these new wireless sensors are using MQTT to transmit the data. So let's say you're connected to a wireless sensor and you're interested in the data, but say, for example, you're only interested in the maximum value of that sensor reading every hour instead of the typical reading every 5 seconds, or that's the data that you really want to get to the cloud. Say you're using Azure AWS and you want to visualize that data in the cloud. So with data flow management, you can add a node with that logic around maximum values, send maximum value every hour, and only send that data to a cloud solution. So only send that downsample data to that cloud solution where you're being billed by the amount of data that you're sending. But then potentially maybe you want to have actually a record of all the data at rest that you want to query. Excuse me. So you send all of that data at the full resolution to a time series database. Here I've got InfluxDB, which is just an example of a time series database, but it could be whatever historian you're interested in using. And then just a couple of other examples. Some you could take in data from an application via an API, do a little bit of parsing on it, send it to a SQL database, or potentially even take in a file. There are a handful of machines that have kind of a file-based output. You parse them within these tools and then send them to the cloud via MQTT or some other protocol.
Right, and here you're focusing that this data is coming from the machine, right? This, looking at file, right? That could be an Excel spreadsheet. If somebody's choosing to, take some of their hourly recordings on the shop floor from a clipboard to a spreadsheet, right? That's a solid move. Now this data could be then gone through a CSV parser and could live alongside with all the other data.
Yeah, exactly. Kind of mashing up. It gives you the ability to mash up data from multiple sources in a single solution. So to make this even more real, to take this out of the hypothetical, let's show a couple of examples of data flow management tools, and the two that we show here are Apache NiFi and Node-RED, just because they're popular examples and we've seen them used in production environments, more of that OT environment. So just a couple caveats here. These are both open source solutions. There are a number of fully supported enterprise options. A couple examples would be BizTalk, MuleSoft. But before I dive further into these, I'll just say that neither PTC, Kepware, nor Mr. IoT are endorsing either of these products. We've just seen them used in a handful of deployments. Wanted to give you a sense of the features that they offer, and certainly this is not an extensive list of features or exhaustive list of features for either of these solutions. Apache NiFi has several built-in connections, just like we say here on the Node-RED side of the slide. Node-RED also has security features, but these are simply the features we've seen kind of be most prominent in the deployments that we've seen. So again, just wanted to give you an example of some of these tools, what we mean when we say data flow management. And I won't go through each of these bullets, but in terms of kind of differentiating them, it does seem that Apache NiFi is a little bit more complex with a fair amount of configuration. So it's more work to set up, but allows users to very granularly see really how and when that data is being transferred, and does have some robust tools around fault tolerance and ensuring data delivery. And then Node-RED, on the other hand, is very user-friendly, easy to get started with, and it does have this tool around the function node, which is really just a node that allows you to input JavaScript and do pretty much anything. So a very flexible solution. Doesn't allow as granular control as NiFi. So hopefully this just helps crystallize what we're talking about here. And I do want to jump to the example from the field that we have, and this example comes from Rowan, which is an oil and gas offshore drilling company. And we kind of joined their connectivity story when they were faced with a changing legal requirement, which stated that safety data needed to be transmitted to and stored onshore. And you can imagine offshore, there's not a whole lot of communication options in an offshore environment. The only connectivity medium available for achieving this goal is satellite, which is notoriously spotty, low bandwidth, high latency, and pretty expensive to transfer data. So in terms of the data that they needed to gather according to these regulatory requirements, they were pulling data from the blowout preventer, the managed drilling systems, as well as some of the electrical systems on the rigs. And so what they did is that they chose Kepware to be able to use a single application on each rig to be able to combine all those or aggregate all those data sources or just connect to all those disparate systems. And then they used Kepware's IoT gateway to convert all of that data into the MQTT protocol and send it to Apache NiFi. So this is sort of where Apache NiFi comes in. And what they did was, which was really pretty innovative, was to use Apache NiFi not only to downsample the data, so they weren't sending as much over a transport medium with such limited bandwidth as I alluded to earlier, but they really use it also to take advantage of the robust fault tolerance and guaranteed delivery tools to ensure that the critical data arrived on shore, even in the case of a temporary communication failure. And so just to, not only did this architecture allow Rowan to comply with these mandatory legal requirements and continue to operate, but it also allowed them to implement other use cases, including predictive analytics around maintenance requirements. So not just a regulatory compliance story, but also performance improvement and improvement in the maintenance side of things as well.
Right. And I want to add to that, looking at those little satellites there, if you think of your network, your industrial and your business network at your factory as being a bottleneck and going through satellites, you envision that, then you really start thinking about that this computation and downsampling needs to move closer and closer to the machine or the process that you're collecting data from. And there's ways to do that. And it's always better to collect less data than more. That gives you, right, it doesn't overwhelm your hardware, your network, but at the same time, it gives you a focus, because you don't want to end up having to look at a trend chart of, 100 different data points and not really having a direction of what improvements it is you want to go after.
Great. Well, with that, Chris, I'll pass it over to you to walk through another example around big data.
Okay, thank you. So this example is something. In the end, it'll make a little more sense. We picked the technology and we implemented it at several warehouses. There were consolidation warehouses, and we thought, well, how can we take this to the shop floor, because it could be applied to other industries as well. So I kind of, it's a pun. I call this data in motion, and you'll see it. You see a little forklift truck there, and typically what happens in a manufacturing scenario and in a process scenario as well, especially for batch manufacturers out there that need to produce high volume, and it could be high variety or low mix or high mix. It doesn't really matter. What typically happens is that you start networking your assets and collecting machine data. And this initiative could grow out of the OT side or the IT side. And a lot of times what you find is that you already have a Kepware server on premise. And whether it's called Kepware KEP server or top server. KEP server also comes with other solutions that you might already have implemented, different SCADA or different analytics platforms that might exist on premise. Then once you start visualizing that data, whether with a brand new Kepware install or your existing one, and with the addition of the IoT Gateway, which opens up a lot of these IT-friendly protocols, now you have the option of sending this data to the cloud. And there's a lot of solutions out there for analytics. You know, you got your Googles and Microsofts and Amazon, and they all provide a certain amount of value if you want to visualize data. And if you structure it in a way where, say, you're going after OEE, right? That's what a lot of people want to go after first. You find that it's a very complex formula. You typically, not all your processes are fitted with the proper inputs to calculate that formula properly. So what you want to really do is start with the O, then move to the E, and then move to the next E, and see how you can tackle them and enforce some kind of standardization around this. Because realistically, even though you're playing in a brownfield, this is brand new. This is brand new to you, and you have the opportunity to do it how you want to do it, and being able to scale it as well, right? Because you don't want to reinvent the wheel from process to process. So here I'm representing the little funnels between Kepware and big data and Kepware and business systems. It's kind of the downsampling layer or your messaging bus. And if you talk to your IT department, they probably already have a message bus in place. So it's a matter of just starting that conversation with them. And here I'm trying to illustrate that as product goes from raw material to work in process and goes through its various stages of processing and eventually ends up as a finished good that's either warehoused or shipped to the customer, you know, operators are your experts. They're going to know the exact flow that this product takes through your factory. Going on to the next slide, then what ends up happening is you're combining transactional data from your existing data collection system, and soon you find that those red dots and the arrows they're pointing in, those are really the points where there's an extra context or an identifier added to the data. And by creating this context, if you think about it as a track and trace function, right, you're able to follow the products through the factory, through the process. And for example, there the blue says work order 1, 2, 3, right? So the data, if you're lucky, you're also collecting data before the process starts and after the process starts, right? That gives you certain timed events and durations that you can take a look at. But outside of that, you know, it's not so clearly defined, because if you're expecting that a batch is going to move from a primary operation to a secondary operation and immediately be worked on, that's not the reality, right? There's scheduling involved. There's different types of constraints. So what ends up happening is that when you look at this data you have, the transactional and the machine data together, there's a big black kind of area where you don't know what's going on with your products because you're not collecting data there. You just haven't, and you don't really need to, because that's not the focus, your day-to-day focus. So I guess going to the slide, sorry, I'm jumping around. Everybody that works on the factory floor, they have their supervisor to report to, or their team lead, and they execute in a siloed environment, right? The downstream operation does its thing, you do your thing, and you're not really concerned about how far along they are. So what we decided to do at some factories, taking our idea that we've developed at a consolidation warehouse, is, well, what if we start geofencing some of these areas where either context or identifiers are added to a product? And what if we're able to track this product through the factory by utilizing technology we add to forklifts or other equipment that can move parts around? And, you know, through the collaboration with operators and training and kind of amending the process that's currently in place, we thought to ourselves, well, maybe we could get visibility all across the factory floor of our products in a real-time sense. And once we did that, you can see the little forklift is, once the product is created at the primary operation and it sits in the little geofence staging area, once the forklift picks up that product, and this technology could supplement, RFID or existing barcoding practices, but once that forklift picks up that batch of products, right then you start tracking the location of that product in real time until the product is dropped off. And what typically happens is, right, some of the product is going to get dropped off into the secondary operations stage area, but in the batching environment, there's going to be somewhere on the side, there's always going to be a pile of parts waiting to be processed next, right? Because we can't always be just in time all the time. It's just not reality. So some of the results that we've seen with this type of application is that by taking a look at the machine data and the transactional data to satisfy the existing ERP and MRP systems, you can derive a lot of KPIs that travel all the way up to the leadership of the organization to help drive the initiatives that need to happen on the shop floor to make processes more efficient, and in the end, generating more revenue for the company, right? That's how a company maintains itself, and that's how it grows. And that's how we can acquire new customers. That's how it plans to purchase new capital equipment. And some of the results that we've seen with this implementation is also that we're also reducing the operational expenditures, such as RFID labels. RFID labels with RFID are not cheap. They're 20 cents a piece. The maintenance of the printers, at some point you're looking at the existing way that data is being collected on the shop floor and thinking to yourself, we could do this a little bit differently because now we've introduced some of these newer concepts. And the coolest thing about this is that the value, right? The value of an implementation like this is less than 6 months. It's less expensive than other types of different implementations. And at the same time, it addresses some of the top concerns of management with, say, when the physical inventory day comes around once a year, and they have no choice but to shut down at least certain parts of production to be able to count the WIP that's on the floor. This is no longer a problem. They can continue running production and have that real-time visibility up to the minute of where everything and how many of those things are in a place. And if you follow, then you follow these products with their geofencing location areas all the way to the warehouse. And once they leave, then the customer pays you for your goods. All right, Jeff, please, if you have anything to add, if you feel like that I missed anything, please or continue.
Yeah, no, I two things that I wanted to touch on was one, the idea of silos, and I think that's where we're seeing a ton of value in these environments, is really breaking down those silos with the, if you think back to the kind of traditional ISA 95 hierarchy that we showed earlier, each of those levels has a specific function, and those functions are critical. But there's also so much value or so much data in each of those levels that can be used to that can be valuable to others within the facility. So as you said, bringing the information all the way kind of up the chain of command and giving visibility where it can be useful is key. And then I think the other thing that is you can extrapolate as kind of a trend in a lot of these Industry 4.0 solutions is going from, batch data delivery to continuous data delivery, so to speak. So instead of, after the fact, looking at, okay, here's how we did over the course of the past 7 days, you're looking at, all right, here's how we're doing right now, and here's real-time improvements that we can make to improve without having to, wait and sit down and do the analysis at the end of the week. So that's a great example. So our last example is around containers and how they're being used. Fairly hot topic in the IT space, and we're seeing certainly some adoption in the operation space, and we're seeing some value. So just to start with a brief introduction to containers. Containers are really most easily compared to virtual machines, which I think is probably a fairly common or well understood concept within the audience. Just because several production facilities have set up virtual environments to host any number of applications. As most folks probably know, VMs allow an organization to run multiple operating systems on a single piece of hardware, as we've got illustrated on the left-hand side of this slide. So they're certainly great for testing or segmenting compute, so there's no interference between different applications. But they are fairly resource intensive in terms of the amount of compute and memory that they use. Adding a new VM to a piece of hardware requires another operating system, and operating systems, just aren't designed to be that lightweight. They require, they take up a fair amount of resource on the hardware. So really, containers provide a less resource-intensive solution. They really just leverage the host operating system so that the application hosted in the container has really everything it needs to run without requiring its own operating system, and thereby uses a lot fewer resources on the host system. And so that's kind of the main value or why containers came into being. But there's a number of kind of ancillary benefits to this type of an architecture. They're modular, so they can be easily updated instead of having to run an update script or whatever on an application. You can just drop in a new container with that application in it. They provide security by isolating the application. So the application within the container seems to that application, it seems like it's the only application running on that machine, where it's actually it's sharing resources across multiple different containers, or it could be sharing resources.
Right, and Jeff, that's why it's kind of like the Apple approach. That's why you don't see many viruses on iPhones, is because it's really sandboxed. Yeah,
exactly. And I think Chris, definitely interested in your experience here, but they can run across multiple operating systems because they package all the application dependencies within the container. Not to say that Linux containers can run in Windows environments, but in Linux environments, one container can run using a handful of different Linux kernels. So it definitely provides some portability.
And with Microsoft, and with Microsoft's big push for kind of having their code run across multiple platforms, it's very critical at this point.
Yeah, absolutely. So this is a really high level intro. This is definitely kind of 101 level. I don't think we have time to do full justice to kind of the beauty of containers, or why they're taking the world by storm. But there's certainly plenty of information out there. Docker has a ton of resources, educational resources, for folks who want to dig into this concept a little bit more. For those folks who we've piqued their interest. But to dive into a technology that's being deployed in operational environments that makes use of containers, I'll just introduce the idea of Azure IoT Edge and give it a little bit of an introduction. So the focus of the product is really to allow workloads that would typically run on the cloud to run on edge-based or on-premises hardware. And so just to directly quote Microsoft, this is a Microsoft product, again, not endorsing it or commenting on it, but just saying that it's being adopted in operational environments, and customers are seeing a lot of value. So better to let Microsoft do the talking on this one. To quote them, they say that by moving certain workloads to the edge of the network, your devices spend less time communicating with the cloud, react more quickly to local changes, and operate reliably even in extended offline periods. And that makes sense. There are certain workloads that you want to, that latency, even the latency of, a couple seconds of getting to the cloud or whatever it happens to be, is too much for a certain application. You want it to be, not deterministic, but certainly less than a couple seconds, or even milliseconds. So in order to efficiently send workloads to Azure IoT Edge, which is sitting down at the edge of the network, which could either be an on-premises server, or it could even be an IoT gateway, or lightweight compute sitting right on the line or out next to the machine. In order to easily send workloads from the cloud to a connected instance of the Azure IoT Edge runtime, Microsoft makes use of containers. And this really just enables users to quickly define a workload in the cloud, bundle it quickly into a container, and push it to the edge. And then in the future, if they need to quickly update or upgrade that the workload, then it can all be done from a central point of management. So I want to make sure we have time for questions, so I'll just give an example from the field, and here you can see that there's a couple of examples of the types of things that you would package into a container, including, again, this downsampling idea that we discussed, and is also capable in a tool, in a data flow management tool. But just to again make sure we've got time for questions, so to give an example, quickly give an example of a manufacturer who's working with Azure IoT Edge. This is a textile manufacturer. Can't give the name specifically, but they're working with both Microsoft and PTC to connect multiple factories on the world. I will give one caveat that they're still kind of in the exploratory phases or pre-implementation phases of this type of architecture. But what they're trying to do, and looking at Azure IoT Edge to do, is track downtime on winding machines across multiple different factories. And they already use Kepware, KepServerEX to connect to those machines. But instead of directly connecting to Azure IoT Hub in the cloud, they're working on deploying Azure IoT Edge to their sites. And there are several benefits to implementing the solution. One is that there's a similar benefit to what we saw with Rowan, which is once you get the data from Kepware into an edge-based compute where you can have a workload and some logic, you can downsample to only be sending to either average or just clean the data so that you're only sending the absolutely necessary data up to the cloud. And again, most cloud solutions are on a consumption based model. And so that's one of the benefits. There's also some transforms that are happening to the data down at the edge. But I think the other benefit that this company is really looking for is that all of this entire system of data collection, including the edge modules, can be centrally managed and updated consistently from one central location. So there's not you're not requiring an army of developers to go out and make changes directly on site or remote in, which could potentially be insecure. you're able to manage all of this from one central point and really standardize connectivity through a single central point. So, Chris, I don't know if you've seen similar deployments or have any experience with Azure IoT Edge or other uses of containers, but would be interested to get your perspective.
Yeah, no, you summed it up pretty well. I guess what I thought about when you started talking about standardization is, you know, I admire the controls engineers that go out there and take the time, because I know how difficult it is updating, say, a work cell that consists of several PLCs, several drives, you know, an HMI, and all that kind of stuff. And they really try to standardize to assign the same IP address ranges across the different devices, but then put something like a Moxa in front of it that could do the network address translation, and it maintains that. And we're trying to achieve the same thing on the IT side. Is you got to standardize. That's like 80% of the battle that I've been seeing.
Absolutely. Great. Well, with that, we've only got a couple minutes for questions, but we'll quickly pass it back to Mark to make sure we answer as many questions as we can.
Great. Thank you, Chris and Jeff. We appreciate your input. We do have time for a couple of questions. The audience may continue to type questions for the presenters in the Ask a Question box on the screen, and we'll get to as many questions as time allows. Ones that we don't get to today will be posted online at controleng.com with the archived version of this webcast. Remember to download a certificate of completion or a copy of the presentation by using the Event Resources tab on the left side of your screen. Now on to the questions. How do you prevent a single IT/OT network from having significant lag if there isn't sufficient bandwidth due to the sharing of IT and OT data? In the past, SCADA networks would provide data to the data management system through a gateway, and this was done to prevent manufacturing data from becoming bottlenecked, which is essential with the plant floor networks not being able to wait for data from production. Either of you like to address that?
Yeah, I mean, a lot of networks are still, right, a lot of machines aren't even online yet. And once you start bringing them online, if, say, it's a Rockwell PLC, yeah, it'll start spitting out a lot of data. It's very busy. It's even more chatty than your typical Ethernet traffic. So I'm always, you know, if the budget is there, having a separate industrial network, hardware-wise, and nowadays, you know, there's also 10 gigabit plus network switches and logical ways to separate the industrial from business networks and assign quality of service levels. But if it's a real-time SCADA implementation, you know, the alternative nowadays is also to start moving the compute closer to the edge, and that's where you really get the benefit of being able to trickle down data that you really are interested in and prioritize it that way as well. And that's kind of how protocols like MQTT address that. Even though it's still an opaque payload, you have ways to format that payload so that it's, you know, and talking about technologies like LoRa, right? That's a very low bandwidth protocol. And you really have to start thinking about what data is critical and what data needs to be kind of transmitted over the entire pipe. That's my take.
Great, thanks, Chris. Did you have anything to add, Jeff?
Yeah, absolutely. So certainly, you know, it's a very good point. I think that, you know, we're definitely not advocating that you prioritize data going to, you know, informative dashboards over data, you know, that's coming from an MES system and scheduling production or verifying production, or from, you know, from a SCADA system, as the question reference. But I think so two things. One is that some of these tools, and as Chris said, some of the tools around edge compute allow you to get a lot of the richness of the information that you need without sending, you know, again, as Chris said, without, you know, just turning a flipping the switch on a Control Logic 5500 and getting all of the data from that solution. And I guess just the only other thing to mention is that there is even more new technology coming that promises to address some of this with 5G. But certainly, as Chris said, if the budget is there, some of the benefits that you can get by consuming and presenting this data in a smart way are huge. So it is worth investing in improving the network if that's necessary. Because as the question mentioned, you can't do this at the expense of existing processes.
Hey, thanks for our speakers. Thanks everyone for the great questions. We'll get to as many offline as we can, so keep them coming until we close the interface. Chris and Jeff, thank you so much for sharing your time and expertise. I'd also like to extend a special thanks to our sponsor, PTC, for sponsoring today's event. Oh, and here are the glossary slides that we mentioned earlier. Thank you for the speakers for putting together this handy 2-slide glossary of terms used in today's presentation. And now that we're just about done, we'd like to hear how we did. The exit survey will pop up on your screen as soon as the webcast ends. Please take a moment to complete it because we use this information to improve our webcasts. On behalf of Control Engineering and CFE Media and Technology, I'd like to thank you for attending. This concludes the webcast. Thank you and goodbye.